interface of this software you can see onto your screen. In the upper side of your screen, you can see this is called ribbon bar, and in this ribbon bar we have different types of tabs. First one is the home tabs, and in this home tabs we have different types of features and tools which you can use during circuit creation and during simulation. Second one is edit tab, and in this tab we have also different types of tools and options to use. You can, when you draw your circuit, view tabs, simulation tabs, loop tabs, tune tabs, and demo tabs. In each and every tabs have more than one tools and the features which you can use during drawing your circuit. In the left side of this corner of your screen, this is called Library Explorer, and in this Library Explorer you have all types of libraries available, and below of this section all those components comes in these boxes which you select into this library. So in this library section you can see here for the hydraulic, the personal hydraulic, pneumatic, the personal pneumatic, drive and transmission elements, environment and control, electric control, JIC standard, IEC standard, digital electronics, and ladder for ABPLC, ladder for IEC standard, ladder for Siemens PLC, ladder for LSIS PLC, electrotechnical IEC diagram, electrotechnical NEMA, electrotechnical one-line diagram for IEC standard, blocks, and HMI control panels. So these are the library which you can use according to your need. Middle of the section, this is called a schematic, and your drawing sheet at which place you can draw your circuit. And in the right side of your corner of your screen, this is called Project Explorer, and you can see here to the steps which you done onto this schematic. Every time you can zoom in and zoom out your schematic using press Control key and scroll your mouse up and down, and you can zoom in and zoom out your schematic. Also, you can use these features of zooming control tools, which is placed on the below side of your right hand screen. Now let's move on to our first topic, which is called how to create your first hydraulic circuit and how can you control your hydraulic circuit using electric control. So first of all go to the Library Explorer and select hydraulic. According to your hydraulic, all those components which are related to hydraulic circuit and hydraulic purpose comes into these boxes. Also, when you click onto this icon, then the sub libraries of this hydraulic circuit, hydraulic library open on your library. You can see here in the, when you click here, then you can see the sub library of hydraulic library open, pumps and amplifiers, hydraulic actuated clutch, reservoir, flow lines and connections, accumulators, actuators, reactional valve, flow valves, pressure valves, and many more components. So you can use particular one by one, otherwise all those components which are needed to create your hydraulic circuit in these boxes. So first of all, take a double acting cylinder from library to schematic. So for this, simply left mouse click onto this component, and without releasing it, simply drag and drop from library to schematic like this. Now take another components from your library to a schematic. So we need a 4x2 normal wall. So click onto it and again drag and drop from library to a schematic. Next one is we need a fixed displacement pump. So take again these components and simply drag and drop from library to a schematic. A hydraulic reservoir, a pressure relief valve, and an engine which is much needed to rotate this shaft. So in this library section, we have no any engines. So you can search your engine in this search filter bar. Otherwise, you know that the engine is drive and transmission element. So simply click onto it. When you select any library, then components comes in this boxes. So select engine from this library and simply drag and drop from library to schematic. You can see here all those needed components which we must need to create your hydraulic circuit onto this schematic, and each components have one and more than one ports which indicate by red color. You can see here, and when you move your cursor onto this red ports, then it converted into the target sign like this. So first of all, click onto this first port and go to the another port and connect here. Again, click onto this red port and connect with this red port. Again, click here and connect with this. Again, click here and connect it with this scissor wire. Click again here. Click one times for 90-degree rotation and go anywhere. Again, click here for 90-degree rotation. Again, click and connect with this scissor wire. When more than two lines are connected at a single point, then it's shown by a dark black spot. It means formation of a junction. So again, click onto this port and double click here to establish the connection between these lines. When this line indicates by red color, it means connection is not proper. Also, when any ports indicates by red color, it means connection is not proper between two ports. So just I want to show here. So when you click onto this port of engine and connect with this shaft, then it's indicated by red color. It means the connection is not proper between this shaft and this engine. And we know that the engine is directly connected with the shaft, so we must need to connect this engine to the shaft directly. So click this component and simply drag using your mouse and connect here. For clear vision, simply press right mouse click onto this schematic and select zoom all components. You can see the entire components in a clear view. So let's move on to the simulation tab and click on to simulation tab. And in the simulation tab, select normal simulation icon. When you select it, then your entire circuit converted into animation form like this. And when you press onto this lever, then you can observe here your piston moves forward, and when you release it, then it's back on original position. But if you want to jam this spool and extend the piston at final position, simply click onto this spool, and this position indicates that your spool is jammed and no any retraction of these pistons. For removing it, simply click onto it, this lever, and remove it. If you want to see the animation of particular components, then select components, simply press right mouse click into it. When you click onto it, then you can see we have two options, context help, and first one is animations. If you want to see the animation, then simply click onto it. Otherwise, if you want to see the details of these components, go to context help options. So we need to see the animation of this cylinder. So click here. When you click onto this animation option, then you can see in a separate window the animation of your particular components of cylinder, and you can observe the animation of the cylinder. Now close this window and stop simulation. If you want to see the property and details of any particular component, simply press right mouse click onto the component and go to context help options. When you click onto it, then a new window comes over your screen. You can see the operation of this double acting cylinder, features of the cylinder, data of this double acting cylinder, technical characteristics of the cylinder, and many more details of this components. If you want to take printout, then you can go to these options. Otherwise, you can close this. Similarly, you can see the components details. Simply press right mouse click and go to context and see entire details, operation, features, technical characteristics, technical data, and many more. And if you want to take printout, simply click onto it. Otherwise, close this window. In this software, if you want to add another more components entire circuit, just like if you want to add one more cylinder in the circuit, simply go to hydraulic library and take one more double acting cylinder. Otherwise, if you want to choose and select same category of double acting cylinder with same parameters, simply press Control key, select component, and press Control key and drag anywhere. You can observe here same type of components and same properties and parameters of components copy onto your screen. Otherwise, you can take from library, simply click and drag and drop here. So you have two options to take same types of components from your circuit and from library. If you don't change any property of the cylinder, then the property is same. Otherwise, if you change any things in the cylinder, then property is different. So you can take from your circuit and also from library. So first of all, I want to delete one component. Also, you can copy, press right mouse click and select copy and paste anywhere. So in this cylinder, we have two ports. So select, first of all, click onto it and connect with these ports. Select another port and connect here. Anytime if you want to change the line of view, simply select lines and you can adjust your line like this. If you want to move your components, then select components and using your mouse, and also you can use the arrow key from your keyboard and move your components anywhere. If you want to add the flow meter from your library, then simply select these components and without releasing anywhere onto your schematic, direct press onto it. But I want to show something just like if you take these components from here and drop onto your schematic. Okay. After that, when you take it and place onto this line, then it comes proper connection. And it's, you can see onto this red port options, because red port indicates no proper connection between these components onto this line. So select component, press shift key and remove from here. Okay. And one more thing, just like when you select component and press onto it, and without using shift key, when you remove this component, then your circuit look like this. It indicates and its connection is not proper. So using shift key, you can move this. And anytime if you want to undo this project, just simply go to this icon and click on it. Now press shift key and move this component from here like this. If you take this component and place onto this schematic, and after that if you want to place onto it, so select shift key. Now take this component and select and drag on, drop onto this line. Now you can absorb this connection is proper. Okay, because at this point it indicates by red color, sorry, black color, it means connection is proper. If you want to add one more components, just like pressure gauge, into the circuit to measuring the pressure. So select component and drag and drop onto your schematic. You can simply drag and drop here and directly connect these ports onto this line by double click onto it. Also, if you want to change the property of any component, simply double click on any component, just like I want to change the property into the second cylinder. So double click onto it. When you double click onto any component, then you can see a new window open on your screen. In the data of this window, we have all types of data, and at this time we have only favorite property of this component. So when you remove this icon and click onto it, then all minor property and each and every property comes in this screen. So you can select and deselect. So I want to add a load onto this second cylinder and see what's happened during simulation. So first of all, select into this kilogram and give it the value like 5,000 kg, 50,000 kg. And if you want to display this value onto your screen, then simply select it and press enter. And now close this window. You can see here this value comes over your screen, and you can drag this value onto this cylinder to confirm that this particular value and load applied onto the second cylinder. Also, if you want to rotate this component, then we have two options to rotate. First one is in the data tab, you can select and go to into the inclinations options and type here the degree and rotate the component. Otherwise, go to the edit tab, and in the edit tab of layout tools, select coordinate and orientation options. In this options, we have of last boxes a degree options available. So you can type here the degree, like any degree, if you at which degree if you want to rotate the second cylinder. So type here and press enter. You can observe here your component rotate at 15 degree. So you can go any both of options. Now let's first of all click onto your screen and select zoom all components to entire components comes in a single diagram. Again, go to simulation tab and select normal simulation icon. You can observe here the pressure gauge shows the pressure at the particular point, and the flow meter shows the flow meter speed of fluid. And when you press onto this lever, then you can observe the first cylinder moves forward and extended forward to very fastly in compared to second cylinder. Because onto the second cylinder, the load applied is very high in the compare of first cylinder is 50,000 kg, and due to this, it's placed onto the forward the piston very slowly in compared to the first cylinder. If you want to increase the speed of the cylinders and pistons, simply click onto this. And at this time, the value is 6.10. You can increase this value. When you increase this value, then you can see the pressure at the particular point is increased. Okay. When you increase this value and after that press onto this lever, then you can observe here the movement of piston is very fast in compared to previous times. So you can adjust your components and circuit according to your need. Now stop simulations. And the next features of to this software to create your electric control circuit and control this entire hydraulic circuit using electric controls. So first of all, go to electric control library. So we have two types of library, IEC and JIC. Both are same, but mainly icon difference in JIC and IEC. In the IEC standard, normal open push button look like this. Just I want to show here, and solenoid DCAC look like this. But in the JIC standard, The normal open push button look like this form, and solenoid DCAC look like this. So both are same, but only icon difference between them. JIC and IEC standard, you can choose any standard. So select JIC standard and take 24-volt power supply from library to schematic. A 0-volt common. Now take a normal open push button. When you release onto your schematic, then it asks alias name. You can give its alias name anything according to you. So you can give its name PB1, P1, a start button, anything, a start and a stop button. So I take its name is start/stop. And press enter. Now take a coil from library to a schematic and also give its alias name, just C1 or whole name of coil. Press enter. Now take normal open contact from library to a schematic, and when you release onto this schematic, then a new window open on your screen like this. And in this window, you can see we have two boxes, first and second. And in the first boxes, you can see a question mark, and we must need to establish the connection and a link between this normal open contact and the coil. So establish the connection between these components, both of these components. Simply go to this alias box and type here C1, because this component indicated by C1 options. So type here C1. When you type C1, then you can see a C1 options comes in this box, and when you double click onto it, then this question mark replaced by C1, and it means the link and connection created between the both of components. So double click onto it. You can see here the question mark converted into C1 form, and previous time this is indicated by black color, and now it's converted by shown by blue color. It means links established between both of components. Now close this window and take solenoid DCAC from library to schematic and drag and drop here. It also asks the alias name, so give its alias name anything and press enter. Now you can see each and every components have one and more than one ports, which indicates by red color. So connect all these ports to each other like this. Click and connect. Click here and connect. Click and connect. Again click here and connect. Your electric control circuit is started and it's completed, but no any link in the hydraulic circuit and this electrical control circuit. So you must need to establish a link between both of circuits, hydraulic and electrical. So first of all, double click onto this 4x2 normal wall and select technical specifications. When you select this option, then entire components of 4x2 normal wall come to middle section of your screen. So now this replace this to this solenoid DCAC. So replace this lever, double click onto it. You can see here we have different types of command sections, different types of command tools in the command section. So select the solenoid DCAC, simply double click onto these components, otherwise simply one click and after that click here. So double click. You can change it, the lever replaced by solenoid DCAC. You can adjust this component using this arrow key, and also you can adjust using your mouse like this. Okay. and press here. Now close this window. I want to show here, just wait. You can observe here onto this solenoid this question mark available. It means it must be need a link, and without any link, no action performed into this hydraulic circuit. So we must to establish a link between this solenoid DCSE to this solenoid DCSE of electric control. So again, double click onto it. Go to variable assignment. And in the second box of alias, type here S1, because in the electrical control circuit, the solenoid shown by S1. So click onto this second alias box. So double click onto it and establish connection between both of components and close this window. Now you can observe here this solenoid and question mark indicates by S1, and both of the same indicates by same color of blue. Now go to simulation tab and select normal simulation icon. I'm sorry for this convenience of internet connectivity. Am I audible proper? Please confirm me. Yes. Oh, thank you. So during simulation, we have different types of measuring instruments and tools which you can use. So in this measuring tools, we have different types of tools to measure the components property. So first one is the component dynamic measuring instrument, which is mainly used to measure the component property. So select it. When you select the component measuring instrument dynamic tools, then your cursor converted into this form, and you can measure the component property. So first of all, select components and again click onto it, and when you drag and drop here, then it asks which property if you want to measure of this second cylinder. So when you click onto these options, then we have lots of actions to measure the property of this cylinder. So you can measure acceleration, linear position, linear speed, output signal force, output signal position, output signal speed, and much more options. So you can choose anyone and select and apply. Again, if you want to check the another property of second cylinder, then simply select, and when you release, it asks which property if you want, then you can apply. And also you can change your unit. Click onto these options, decision, and if you want to record this value, select these options, otherwise press OK. Similarly, you can measure the property of another components, same like this. Anytime if you want to disable these functions to this cursor, simply press right mouse click onto your schematic and disable it. This is single node dynamic instrument, so you can use it to measure the component property and fluid property at any particular point, but you can use it at those points at which the connection of 2 points are established. It means, and when you move your cursor and placed any particular joining point, then it's shown by target color like this. But if you move onto this particular lines on any particular place, then it can't shown like this. Okay, so you can place at those points where joining is established and available. When you release it, then it also asks which property you want to measure. So we have different types of properties. Just you can measure the pressure, density, temperature, and viscosity at this particular point of fluid, and you can apply. Similarly, if you want to measure at this point, then select, and when you release it, then it also asks which property you want to measure, and you can choose anything, just like viscosity, and you can change the unit of this viscosity according to your need and apply. So this is called a single node dynamic measuring instrument for disable this function. Simply press right mouse click. This is double node measuring dynamic instrument, which is mainly used to measure the differential pressure at two different points. So you can choose any two different points to measure differential pressure, just like here. And again, go to any point, and you can measure differential pressure at two different points. Okay, and apply. For disable this function, simply press right mouse click. When you press onto this start and stop button, then you can see the value into this separate box, just like this. Okay. So you can use these tools and measuring instrument during simulation. Now stop simulation, and I want to remove this measuring instrument. So select it. If you want to delete all these measuring tools at single times, simply select first of all any measuring instrument options, and after that press shift key and select all those options which you want to delete, and press delete key from your keyboard and remove entire at single times. Let's now move on to the next features of the software to plot your graph. So in this measuring tools of simulation tab, we have three types of plotter: YT plotter, YX plotter, and ZXY plotter. So you can choose any plotter according to your need. If you want to draw the graph in 3D diagram, so you can choose ZXY plotter. And otherwise, if you want to plot the graph in 2D in the YT form, then you can choose it. And if you want to XY plotter, then select this. So I want to plot any one to only show there. So select it. When you press onto it, then a plotter comes over your screen, and you can plot the graph onto this plotter. Yeah. You can see onto your screen, a plotter comes over your screen. So if you want to plot the graph of any particular cylinder, so you can take from your library, and from your schematic and drag and drop onto this plotter. First of all, select component, and without releasing it, drag and drop onto this plotter. When you release it, then it asks which property you want to plot: acceleration, linear position, linear speed, output signal force, and many more options. So you can select any one options. If you want to select all these options, so simply click onto this checkout box, and you can display this plotter. So I want to show here three property of this double acting cylinder. Just two property: acceleration and linear speed, and apply. Also, I want to plot the graph of second cylinder. because onto the first cylinder no load apply, and onto the second cylinder load apply very high in the compare of the first cylinder. So simply select it and drag and drop onto this and select two mode options and apply. Now go to simulation tab and press normal simulation icon. And when you press onto this key, then you can absorb the graph plotting, and one cycle is completed, please stop simulation. You can zoom and extend the size of plotter simply like this, and you can compare the graph of first cylinder and second cylinder. But you feel you have doubt to which color indicates the first cylinder and second cylinder. So simply for this, select this icon. When you select this icon, then onto the plotter of your screen, you can observe here the acceleration of first cylinder, linear speed of first cylinder, acceleration of second cylinder, and linear speed of second cylinder. When you move your cursor onto this options, then the graph indicates by dark color like this and gold also. So this line indicates, the yellow line indicates the acceleration of first cylinder, and if you want to see the acceleration of second cylinder, then it indicates by this color, and you can see the difference between both of the cylinder, because on the first cylinder no load apply, and but the second cylinder the load apply very high in the compare of first cylinder. So the graph between both of cylinders is very changes. So you can use these features. Also, if you want to find out the delta t value at two particular point, so select this cursor option. When you press onto it a single time, then one cursor comes over your screen. If you want to take one more, so again click onto it, and you can place at two different points, and you can find out the delta t value. And delta t value you can see on your screen. If you want to take the printout of this graph, so simply go to printout options, and also you can take copy of your graph, select it and go to WordPad. And paste onto this. Like this, you can see here the same type of graph comes over your screen, and you can plot your graph, and you can take a copy of your graph for any other purpose, for during presentation and many more purpose. So you can use these options. So from using of these features, you can draw and see the graph, and you can also observe the plot and the graph of the particular components. Now close this graph, and let's move on to the another features of the software. During simulation, in the troubleshooting tools, we have different types of tools to measure the value and a particular point and the pressure and the temperature of the components, fluid. So for this, we have two types of tools. First one is the pressure gauge. So when you click onto it, then a virtual pressure gauge comes over your screen. You can place anywhere, and you can measure the pressure at the particular point. Also, you can use a thermometer to measure the temperature. Okay, so you can use both of the tools. Also, you have a hydraulic tester, so you can use this hydraulic tester. In this software, you can see the faulty components anytime. So before discussed onto this, I want to show here the repair and failure tools. So you can activate failure inside your circuit. So first of all, select failure tools into the troubleshooting option. Select it, and you can select the components in which you want to create failure. So select any components. When you select it, then you can see an on options comes into your screen. So first of all, select jam spool and failure activate and apply, and press onto this key. You can observe here this 4x2 normal wall moves from at this position to this position, but no any movement onto this piston because failure activated into this circuit. So if you want to remove this, simply go to repair tools, select component and select all failures and apply. And you can observe the piston moves forward and backward properly. Now stop simulation. We have one more options to activate failure. So first of all, select component, double click onto it and go to troubleshooting option. And from here also you can activate failure. Okay, so now close it. If you want to find out the failure components and another failure tools, so first of all, select this icon, go to project and select project property. When you select property, project property, then lots of options comes over your screen. And if you want to find out faulty components into your circuit, so select monitor faulty component and apply. And close this window. Again, go to normal simulation icon. How to know that which components and which point is failure components and monitor how to monitor faulty components. So when you press onto it and click here, then you can see a message onto your screen and it indicates by red flag onto the right side of screen of ribbon bar. Also it display by yellow color of triangle. When this piston reach at this position, then at this point you can observe here yellow color triangle comes. It means failure. You can monitor faulty components. Okay. Also, if you increase the value like this, then you can clearly observe the failure tools and monitor faulty components at this time. And when you press onto this message box, then you can see the component V2 maximum flow exceeded on connector unknown. Okay, so from here you can read the message which type of failure, and for disable it, simply click and decrease the value. Okay, and again press onto it to check it failure or not. So it can't show, it means this displacement value is sufficient for this circuit. Now stop simulation. In this home tabs, we have another more features like reference options, bill of material. So you can use reference option to get the reference to the particular components, and you can use these options into the examinations, just like select components, and when you release it, then it gives the reference just like first, second, third, and so on. And disable it, press right mouse click. In this home tab, we have lots of drawing tools like CAD tools, and using these CAD tools you can draw the ellipse, lines, rectangle, arc, polygon, and line text, and so on. And if you want to take copy entire this circuit, simply select all, Control plus C to copy this and go to WordPad and paste here. Select all, press right mouse click and copy. Also, you can copy using Control plus C option. And paste here. You can see same type of circuit comes over your page, and in the examination you can ask the name of first component, name of second component, third component from the students, and so you can use these features in the examination point of view. So this is the feature of this software. Also, if you want to generate your bill of material, it means use single time, two times, and which type of components used to create your hydraulic circuit. First of all, I want to delete it, and so simply select this bill of material option, and when you click onto this schematic, then a bill of material generate onto your screen, and on this bill of material you can see each and every components comes in the separate bill of material, so you can't count any components. Just wait, it will take few seconds. Is any queries? Please ask using chat box. Yeah. You can see here a bill of material comes over your screen. The component at single times, reactional block at single times, level cylinder two times. And if you want to check which components at which place, so simply press Control key first of all and press onto this coil. Then you can see it's shown by a separate box, and you can find out very easily. But it can be possible for those components which you used at single times. But if you press Control key and select double click center, then it can't indicate in separate box because it used two times. Okay, so you can see the bill of material of this entire components and circuit. Next feature of the software, to create your report card, so select document option and go to separate sheet report option. When you select it, then you have different types of options to separate generate your report card, like bill of material, purchase list, tag list, document list. So if you want to purchase any lots of components, then you can select purchase list option and press OK. Now you can see here purchase list comes over your screen. So you can see the boxes, and in this entire boxes you can give the part number of components and quantity, length, which company manufactures the components, catalog descriptions, types of discounted, subtotal, and owner identification. You can give the any details of the components, and you can purchase. When you fill the particular value of components, then overall value comes at this place. So you can generate your report card using these options. Otherwise, close it. Now let's move on to the another and most important features of this software. This software provides the picture adding tools. So using these features, you can show the actual figure of any components and 2D figure of components. So simply go to picture in drawing tools of home tab and drag and make a box like this, and when you release it, then your systems have diagram onto your system. So I have pictures of 2D cylinder, the rectangle cylinder. So select and open. This feature is very useful for students because sometimes students only see the 2D diagram of any components, and when they go into the market, then and original components comes into the front of him, then they confuse which type of components is this. So you can use these features and compile both of this cylinder and this cylinder. Simply press Shift key and select component and press right mouse click and go to select group option. Now we can observe both of the components 2D and 3D grouped at a single point. So students can easily understand the 2D diagram of development cylinder and 3D diagram of this cylinder. Similarly, you can take another pictures of 4x2 and normal from internet and save the picture into your system and go to picture options. Simply drag and drop, drag boxes like this and take the pictures from your system and group with the 4x2 and normal one, and show how to create your hydraulic circuit. Also, another features of this software to create your personal library. When your system the software is new, then you have only one library, generic components library, but you can create your personal library like PLC, and I create your one more by name, my name with Sushant, Hydra, and many more. So if you want to create your personal library, first of all select this icon, click onto it. It asks you the file name, just library name, so you can give anything and press enter. Then you can see here the HSSH option comes in this library explorer option. Okay. When you click onto this icon, then a library create into your HSS library explorer. When you again click onto it, then sub library create. Okay, like this. When you remove and again click, the new library open. So you can create your new category of library, sub library, and a new library. So in this library, you can save your diagram. So you have two options to save your diagram. Simply select component like this and drag and drop onto this library option. You can observe here this double acting cylinder and this 3D diagram of double acting cylinder. Same type of components saved into this library, and you can anytime drag and drop onto your screen. Okay, like this. Also, if you want to draw save entire circuit into this library, then also first of all select all, press right mouse click and select group option and drag and drop into this library like this. You can absorb same type of circuit saved in your library. So you can use these features and save your circuit for future purpose. And without wastage of time, you can create your circuit like this. So this is very important features. This to create your library your personal library, and you can also add 3D diagram and 2D diagram of different types of components to show your students. Is any queries, please ask. Otherwise, we move on to the second topic, onto the how to create your pneumatic circuit. Okay, so let's move on to the another topic. So first of all, I want to delete all those components. So select all and press right mouse click and select delete. To create your first pneumatic circuit, first of all, go to Library Explorer and select pneumatic. Now you can observe here only pneumatic components comes in this below box. So take those components which you need to create your pneumatic circuit. So first of all, take a double acting cylinder from library to schematic. 5x2 and normal wall. And drag and drop here. Of 3x2 normal wall and drag and drop from library to schematic. 2 exhaust. And you can simply direct connect here. Otherwise, you can connect with the line diagram. Take one more exhaust and connect here. And one pneumatic pressure source onto this red cord. And establish link between these ports. Now click onto this for perfect clearance vision. Press right mouse click onto your schematic and select zoom all components. Click here, click and connect. Again, click here, click and connect. So this is basic circuit of pneumatic. And go to simulation tab and select normal simulation. When you click onto this lever, then you can see the movement of your piston, and the message indicates the component F4 maximum speed exceeded. It means it's find out the faulty components, because we select the faulty components in this previous diagram of hydraulic. Due to this indicates. Okay, so if you want to decrease the speed of this piston, so simply first of all stop simulation and double click onto this pneumatic pressure source and go to data tab. In the data tab, we have different type of options. At this time, we click onto this favorite property. So we have only shown 5 property. So from here, you can increase and decrease the value of orifice diameter. Due to this, the fluid flow is decreases just 0.1 and press enter and close it. And now again, normal simulation tab and press onto it. At this time, this value is much more, and due to this, this message indicates. So first of all, again, stop simulation. Double click onto it and type here the value 0.0136. Press enter. Again, go to normal simulation and press it. You can clearly observe the movement of this piston for extend and retraction. Now stop simulation. Now let's take to another circuit. For mechanically piloted valve from your library, and simply drag and drop here. Take one more at this position. Now select components. Go to edit tab. Go to position and select rotate left 90 degree. And go to position and select flip vertical. Similarly, select this component, go to position option and rotate right 90 degree. Also, you can rotate the component, simply press right mouse click and go to transformation option and choose anyone. Okay. Again, select it, go to position and flip vertical. Let's take this component and press at the end of this piston. So take from here and paste. For better visibility, press Ctrl key and zoom it. Now again double click onto it. Go to extension options and type your 100% extension. Press enter. Now close this window and place it at the end of this position. Again, go to data tab of double acting cylinder and type your extension 0%. Now double click onto this 5x2 normal wall. Go to builder option and replace these components by another tools. So first of all, select it and delete. Now double click onto it and replace the another command by external pneumatic pallet valve and click and select. Again, click onto it and replace by same tools, external pneumatic pallet and apply. Now close this window. Click onto this red port. Click here for 90 degree rotation. Click again. And connect. Similarly, click here. And connect it. Click onto this line. Press right mouse click. Go to line function and select pilot. Same for this line. Press right mouse click. Go to line function and select pilot. Now take two exhaust and two pneumatic source from library and place here. Take one more exhaust or this point and one pneumatic pressure source. Connect this. Go to position and select rotate right 90 degree. So now select this exhaust, connect at this port, go to position, select this pneumatic pressure source and at this point, go to position, rotate left 90 degree. Select this component and add here. Again, go to position and rotate right 90 degree. Okay. Select simulation tab and now press on to normal simulation icon. At this point, you can absorb the movement of this piston. When this piston reaches this final position, then both of the components are touch with each other, then it back to below side of direction and piston back original position. When again it comes back original position at this point, then it touch to this piston last end and go to backward. And from here you can absorb the failure component. So for this, stop simulation. And also you can deactivate failure. Simply select this icon. Go to project option. Select project property. and deactivate monitor faulty component. Close this window and again select normal simulation. You can observe the movement of your circuit and know any failure shown onto your display. Okay. So from this way you can create your basic pneumatic circuit, and also same tools you can use for the measuring the instrument, using the instrument to find out the measuring components, tool, fluid property, and so on. Now stop simulation. Let's move to create your electrical control circuit to control the pneumatic circuit. So first of all, we must need to remove all these components. So select it. Press Shift key to select all those components at single times. Also, you can delete one by one. Just wait. Select and press delete. Select, press delete. Select and delete. Select and delete. To create your electrical circuit to control this pneumatic circuit, first of all, we need a 24-volt power supply. So go to GIC standard, take 24-volt power supply for 0 common volt, normal open push button, give its alias name anything, just P1, press enter. Take a proximity switch, a coil, give its alias name C1, press enter, normal open contact, and establish the connection with C1. So in this alias, type your C1 option and double click onto it, and now close this window. Now take a solenoid DCSC from library to schematic. Give its alias name S1 and press enter, and give its alias name S2. Press enter. Now take one more proximity switch from library to schematic. Now establish the connection between these ports. So click here and connect. Then click here and connect here. Click and connect. Click onto it and connect. Click here. And connect. Click here and connect these ports. You can adjust your components. Simply select component and move up and down using arrow key of your keyboard, and also you can move it using mouse. So your electric control circuit is completed, but no any connection between this pneumatic circuit and this electric control circuit. So first of all, we need two sensor to establish this connection between this sensor switch. So first of all, take Go to pneumatic library and take sensors from library. Take one and place at this point and give its alias name A0 or A1 anything. Press enter. Press double click onto this cylinder and go to data tab. In this data tab, give the extension 100%. Press enter. Now close this window and take one proximity switch and place at the in position of, at this position of. Again, double click onto it. Go to data tab and select extension 0%. Press enter. Now close this window. Now double click onto this 5x2 normal valve and replace this. First of all, go to builder and replace this pneumatic pilot by solenoid DCSC. Similarly for this, and apply. Now close this window. Establish the connection with solenoid S1 to this solenoid and second for this solenoid. So again, double click onto it. Go to variable assignment. Select first solenoid. Select first solenoid and in this alias of boxes type your S1 and double click onto it to establish connection. Now select onto this second solenoid and type your 2 because the name of second solenoid is indicated by 2 and again double click. Now close this window. So we established the connection between this solenoid S1 and 2, but no any link with this sensor and this switch. So double click here. For the first sensor, type your A1 and establish link. Now close. Again double click onto it. On second alias of box, type your A2 and establish connection. And now close this window. Now select normal simulation icon and you can absorb the movement of piston. When it reaches at this position, then it's back original position immediately due to this sensor and sensor switch. So you can use this software to create your hydraulic circuit, pneumatic circuit, and so on. Same type of plotter you can use to draw your plot and graph to the components. So each and every features are same which we discussed in the previous. So let's now move on to the electrical purpose. If you have any queries, please ask using chat box. Is any queries? Okay, so let's move on to the another topics to create your electrotechnical and PLC programming. So for the PLC programming, first of all, create all the entire components. For PLC programming, first of all, go to again pneumatic circuit and take a double acting cylinder from library to schematic, a 5x2 normal valve, two exhaust and one pressure source. Check and connect here at this port. One more at this port. and a pneumatic pressure source at the middle of this port. Okay, now connect it. Please wait, due to some error, it takes some time. If you have any queries, please ask using chat box. Until this software start again. Okay, so first of all, go to pneumatic library, select double acting cylinder and drag and drop onto your schematic. Now take 5/2A normal valve and drag and drop here. Two exhaust and one pressure pneumatic source, and connect here onto this port. And establish link between these ports like this. Go to Home tab. solid simulation tab and press normal simulation icon. When you click onto it, then you can see the animation form of this circuit, and you can see the animation. Simply press right mouse click and see the animation of the particular component. And also you can see and use the another features which we discussed in details during hydraulic circuit formation. Now go to ladder for ABPLC. And select sub-library of ladder for ABPLC. When you select sub-library, then you can see the sub-library of this ladder for ABPLC. And we have different types of library in ladder for ABPLC which you can use during circuit formation. First of all, go to electric control JIC standard sub-library, and in this sub-libraries, go to PLC card and take PLC input card and output card onto your schematic. Now close this sub-library of this JIC standard and select 24-volt power supply and place at the end of this point. Take one more for this output PLC card, a 0 common volt at the end of this position of PLC card. One more and for this in the position of output PLC card. Normal open proximity push button and give its alias name P1 and first, second, anything. Press enter. Take a solenoid from library to schematic and place onto it. Give its name and press enter. Now connect it to each other, these components like this. We can connect, click here and connect with common. Now go to ladder for ABPLC and take a rung from library to schematic and paste between these cards. You can see here the cards, this rung overlap onto this PLC card, so you can adjust the size of this rung. Okay. Now take examine if closed from library to schematic and paste onto the first position of the port, and select output energized from library to schematic and again placed here on the first port. Give its name out 0, simply out and press enter. Now connect it. We can connect here. Okay. Double click onto this component and establish link with PLC input card input 0. So double click here and in the alias box type here input 0 IN. We are on option of input 0, so double click here to establish link. Now close this window. Similarly, double click onto this output and establish link with output 0 of output PLC card. So type here and double click onto it and now close this window. Go to normal simulation icon and press onto the switch. So at this time you can see no any action and no any link between this pneumatic circuit and this PLC programming cards. So first of all, stop simulation and create a link with solenoid S1 to this solenoid. So double click onto this 5x2 normal wall. Select this solenoid And in this alias, type your S1, press enter, press double click onto this S1 option and close this window. And now select normal simulation icon. And when you press onto the switch, then you can observe the piston moves and it's operated by this PLC programming. Okay. You can adjust your movement of this piston. So first of all, stop simulation. Take 3 more examine if flows from library to schematic and placed at all 3 positions of this port. So take and place here. Again, take one more, and first of all select this component, press shift key, and it moves from first position to third position. Okay. Take one more output energized from library to schematic and placed onto it, and give its alias name, anything, just ABC. Press enter. Now connect this established link between this output energized with examine if closed. All of 3 components is must be connected to a link with ABC. So double click onto it, and in this alias type your ABC. Double click onto it and establish link and close it. Similarly for this component. And for this. Now establish link. Connect these ports like this. Then click here and connect. Click and connect. In the ladder for ABPLC, click onto this sub library, and from here, the sub library of ladder for ABPLC, go to timer library and take timer on delay from library to schematic and paste here and connect these ports. Again, close the sub library, and now take one examine if open from library to schematic and directly paste on this line, because when you drop onto anywhere on this schematic and after that you can take and drop onto this line, then connection is not proper. But when you take from library and directly take and drop onto this line, then connection is proper. So you can see here a question mark onto this component. So we must to create a link with this time on delay and in this component. So in this time on delay, you can see your DN options. So double click onto it, and in this variable assignment of alias, type here DN and double click onto it. And now close this window and go to normal simulation icon. When you press onto switch, then you can see the piston moves and stop at this particular point, and there is the timing of this stoppage of this piston is 10 seconds, because in this time on delay the preset value is 10 seconds. So you can change this value and adjust your speed and stoppage of your piston. If you want to increase or decrease your speed, increase the orifice's diameter of this pneumatic pressure source. And if you want to set the preset value, simply first of all stop simulation and double click onto this time on delay. Go to data tab, select deselect the favorite property, and in this property of this time on delay, you can see the preset value, and this value is 10 seconds. So if you want to change this value, just like 3 seconds, 5 seconds, 6 seconds, and press enter. Now close this window and select normal simulation icon. After 6 seconds, it comes back original position. Okay. So you can change your preset value, and do using this software you can programming your PLC programming and use the PLC cards. Also you can draw the graph using YT plotter, YX plotter, ZXY plotter, and you can use its tools to measuring instrument tools to measure the fluid pressure, temperature, viscosity, and property of any components. So you can use this. So if you have any queries, then please ask. Otherwise, we move on to our last topic, to how to create your first electrotechnical circuit using this software. If you have any queries, please ask. Otherwise, we move on to the next topic. So please stop simulation and delete all these components. Go to library section, and we must create your electrotechnical. So select electrotechnical library. When you take any components from library and drop onto a schematic, then it can't possible. Just I want to show here. Take and drop here. The message shown, this section is not completed with this type of document diagram. Okay, so we must to change the diagram and the schematic. So first of all, go to Home tab, select Document, and for this electrotechnical, select electrotechnical diagram option. Please wait. Select electrotechnical diagram. When you click onto it, then it asks which type of template you want to choose. For IEC standard, you can choose first option. For NEMA standard, and you can use default for both of the standard. So select default and press OK. You can absorb the schematic change according to the electrotechnical purpose. So let's now first of all create a basic RLC circuit. For this, take a AC source from library to a schematic, a resistor, a coil from library to a schematic, and simply drag and drop here, and a capacitor. For better visibility, simply press right mouse click onto your display and select zoom all components. Okay. Select this component and rotate it using your mouse. Simply right mouse click and go to transformation option and rotate right 90 degree. Similarly, for this component, press right mouse click, go to transformation and press it. Now connect each ports to each connect each other ports using your mouse like this. Click here and connect. Similarly, click here and connect. Click and connect. So your basic RLC circuit is completed. So now let's select to simulation tab and press onto this normal simulation icon. You can see the animation of this RLC circuit, and you can select to multimeter to measure the AC voltage and the current mode. So first of all, on this multimeter and measure the voltage, AC voltage. Now take red port onto this point and black probe at this time. You can observe here the value is 229.96 volt, and it means you can say the approx value is 230 volt. Okay, so you can use this multimeter and another oscilloscope for measuring other details of this circuit. Now again off it and take a disconnector, click onto this point and move onto this line and disconnect. Okay, to measure AC current mode. So again go to AC current mode, check red probe and place at this position and black probe at this position. You can see here this value indicates 189 milliampere. So you can use this software to create your basic RLC circuit, and you can use the multimeter clamp and two-node dynamic instrument, three-node dynamic instrument to measuring the three different points. Now close it and move on to the create your basic electrotechnical circuit. To create your basic electrotechnical circuit, you need first to three-phase AC source. Three-phase source, a thermodynamic circuit breaker from library to schematic, a connector 3-pole, give its alias name, anything, just press enter. Now take a connector 3-pole and simply drag and drop here. You can adjust your component using your arrow key and also with your mouse. Now take a synchronous motor from library to schematic and simply drag and drop here. Now go to home tab, and in the wire section we have different types of wire. So take a polyphase wire to connect these ports. Also you can connect this one by one. So I want to connect these ports with the help of polyphase wire at single time. So select it and connect here. Again click onto it and connect. Click here and connect. For disable this function, simply press right mouse click onto your screen. Now take out transformer from library to schematic and simply drag and drop here. Two ground, one for this transformer and another for this synchronous motor. Now select a ground wire from your wire section. Click here and connect this transformer. Click and connect with this synchronous motor. For disable this function, simply press right mouse click onto your screen. To command with the electric control circuit, now take a command wire switch. Switch. So select normal push button and simply drag and drop onto your screen. Give its name anything. Start. Take another switch, push button with circuit breaker. and simply drag and drop here. Give its name. Stop. Now take a coil from library to a schematic and drag and drop. Now establish the connection between these components. So first of all, go to wire section and select command wire. Click onto it and connect here. Again, click onto it and connect here. Click onto this red port. Click and connect. Click, connect, click, click and connect. Disable this function. Now we have two more ports which can't connect. So again, go to wire section and select power wire from this section and click onto this first port. Click here, click and connect. Similarly, for this second port, click and connect. For disable this function, simply press right mouse click onto your screen. So your basic electrotechnical circuit is completed. If you want to add more another tools, just like ammeter, wattmeter, then you can add entire your circuit. So if you want to add a meter into the circuit, so you can take onto a screen and you can adjust the size of this ammeter. And placed onto this line. So using shift key to proper connection. Press shift key and press onto this line. Okay. Now go to simulation tab and select normal simulation icon. When you move your cursor onto the component, then it indicates by hand mode, and it means you can active this component. So click onto it, and when you press onto this start key, then you can see the action of this. Just wait. Yeah. Something else due to this, no any action in this circuit. So first of all, stop simulation. We know that must needed to establish the connection and a link with the two components. So we must need to establish link with coil C1 to this component connector with 3 ports. So double click onto it, and in the search box of alias, type here C1 and double click onto it to establish the connection with this component. And now close this window, and now select normal simulation icon. Activate AC breaker, and when you press start key, then you can see this synchronous motor start to rotate, and the value of angular speed is 1472 rpm, and output torque. For better visibility, simply press right mouse click onto your screen and select zoom the components. Sorry. Okay, you can observe the value. When you increase this value, then you can see the angular speed is decreases, and due to output torque is very high, the system go to shutdown. Okay. So for stop this simulation, you can absorb the value onto your screen. Okay. So for stop, first of all, deactivate it, and now Stop. We can use these components to measure the details of any particular point of AC current flow and so on. Also, you can use a plotter to draw the graph. If you have any queries regarding this software, then you can ask question using chat box. Otherwise, we move on to the one more features of this software to teach here, which is very useful for students and teachers, which we discussed during the presentation. So if you have any queries, please ask. Otherwise, we move on to the another features of the software. Power stop simulation. Select technical. You have two options. First of all, to select home tab, and in this catalog manager, we have our hydraulic options of teachwares. So in this hydraulic, we have different types of topics. First, physics, circuit drawing, components, circuits, how to troubleshoot a virtual test bench. So I want to show here for just one topic on physics. In this physics, we have different types of topics for Pascal principle, flow, pressure loss in orifices, or pressure compensation. So you can choose any topic and open it. It takes few minutes, so please wait to complete this section. And if you have any queries regarding this software, you can ask. And if you want to contact with us, then you can contact from this way using this number. Is any queries, please ask using chat box until this process is complete. Now your action is complete and ready to start. So click here. The student can give the date of examinations on name, and according to questions they choose answers. When you press onto this game mark, then it sends you can read this information, and according to this do in the software and give the question answers. Again, click onto it. If you want to take printout, then in the end of the section, you have an options to print out. So you can use the features to take print out this question and answer session. In the last, we got a printout options, and just wait. So according to question, you can give answers. And if you want to take printout this copy, then simply select these options for printout in PDF. Otherwise, if you want to close this session, simply close this project. Is any queries regarding this software? Please ask using chat box. Otherwise, we are moving on to the end of this presentation. And I hope you learn something about the software and know the features of this software. Is any queries? Please ask. And if you want to contact with us, simply contact onto this number. So thank you for joining with us. Thanks to everybody who joined this session.